Next speaker is Casey Reas. He's based at the University of California, where he is a professor of design and media arts, particularly known for his mural art, which is derived from initially hand drawing and then scripted software processes, which seem to never give totally predictable ways in which the final product is going to come out. He has shown his work widely here and all over the world. His talk is called Conditional Drawing.
Okay, thank you very much. It's very good to be here today. So, in my mind, drawing's a way of thinking and exploring, and it's not tied to a specific medium or a specific material. So with that, we'll dig in. This presentation could also be called Drawing with Code. I'm kind of a double evil presenter today. Not only do I use computers, I actually program them myself. I like to think of code, computation, computers, as a subset of a larger theme, larger topic that I find more interesting, which is working in systems, working in patterns, and working with instructions. So we have 5 topics today. The first one is ideas. So now we're 1965. We're in Stuttgart. Frieder Nacke, the creator of this plotter drawing, is a mathematics student. He's one of the very first people, one of the 3 people in the world, to produce plotter drawings with aesthetic intent, rather than to produce engineering drawing. In this particular drawing, there are a lot of random values being used. So here's a rhetorical question. In 1965, why are random values a core component of software and computing machines? Computing machines are for accuracy, for speed, for clarity. So the position and location and the density and the pen used for each one of these hatches was determined by random operations. This is the computer. This is the computer operator sitting in his temperature-isolated booth. In this case, Frieder Nacke, who wrote the software, the aesthetic protagonist in the story, has no contact with the actual machine. This is the front panel. This is the back panel. Here you can see all the soldered, hand-soldered connections, all the vacuum tubes that perform the logic. These are the tape drives which store the information. And this is what gets spit out of the computer. This is the paper tape, which is fed into the Zoo's Graphomat Z64. This is a 2-ton, 2-axis plotting machine. Here you can see it drawing. The pen can go up and down. Many different kinds of materials can be placed inside. Having said a little bit about the machine, I now need to say that I don't care about the machine really at all. What I'm interested in is the logical process in the system that the artist in this case is writing in order to control that machine. So here we have an image of Frieder Nacke doing the work I'm interested in. He's writing the program. In this case, he's doing it with paper and pencil as a series of logical diagrams. So now we move back to 1913. We have Marcel Duchamp. I think many of you know this work. The basic idea is you take a piece of string that's 1 meter long, and from 1 meter high you drop it onto the ground and then fix it there. That then becomes the standard units that Duchamp uses in later work. I'm interested in this as a critique of standards and critique of units of measurement, but more importantly, as a tool. So Duchamp built his own tool, his own set of drawing templates that he used to produce further drawings. So here we have a piece from 1914. And then here, it was integrated into the large glass. These areas here were produced by the stoppage curves. So moving forward in time, 1963, Ivan Sutherland in the Sketchpad system. This was at MIT. So here we see Sutherland sitting at his machine drawing. This, in my opinion, is the most interesting early CAD system. It was direct manipulation with the light pen. And although it was an oscilloscope screen that was blinking in really low resolution, he was able to draw in geometry on an infinite canvas. He was able to zoom and scale and produce work, make templates that then could be reproduced within the system. Light pens at that time were a dominant way of interacting with the machine. It was more direct than the indirect mouse and keyboard. And I think what I'm most interested in about Sketchpad is the way it combines the sort of technical precision needed for technical drawing with the natural motions of man, our idiosyncrasies, etc. So here you can see, for example, the drawing that was done by the person with the light pen, and you can see the result there. So we're able to take a mark, an organic mark, and then produce a fine sort of perfect geometry line from that. I'm more interested in not the fine lines, but I think this is an interesting hybrid system. All right, now 1958, we have Jean Tinguely making his metamatic drawing machines. Here's the artist himself with one of his machines. This one is powered by a bicycle. What I think is really interesting about these machines is we think about the 1950s, we think about computers, we think about order, we think about centralization of power, we think about clarity and precision. Jean Tinguely is doing the exact opposite. He's using motors, he's using mechanisms to create chaos, disorder. And I think in many ways it's a more interesting statement as an artist, sort of against the movement of the sort of technocratic society. All right, now 1967, we have Logo. Logo was an extraordinary system. Here we have a plotter that's unconstrained. It's free-range plotter. It also has a pen that moves up and down. And Logo had its most sort of important impact when it moved to the home computer environment. So here we can see the robot, this extraordinary drawing device, has been turned into a few pixels of a triangle, which you see here. What's interesting about Logo is the way it defines drawing. So in Logo, it was a system really made for children to develop an understanding of geometry. We remove the Cartesian grid. So you don't draw a line from coordinate 2030 to coordinate 8100. You are the system that's drawing. So you draw relative to yourself. This is something that maps to a more natural mindset. So I walk forward 100 steps. I turn right 120 degrees. I walk forward 100 steps again, and that performs a triangle. So this other way of thinking about geometry, which is centered in the individual, I think is what's extraordinary about Logo, but then also putting that into a syntax, which is also very straightforward to allow people to draw using software. All right, Witt, wall drawings, 1968 through 2007. What I'm interested in with Witt is the way that the drawing is encoded as a piece of English text rather than computer code that then is executed by a draftsperson, first by Witt and later by a draftsperson. So if we look at wall drawing 325, we see on a black wall, white horizontal lines, 2 straight, 1 crayon, 1 wood, 2 not straight, 1 crayon, 1 rope, 2 lines are equally spaced. So we have this notation which is ambiguous. There's many ways this can be executed and performed, almost like a score. This is an example of one of the Wits drawings. I think you're probably familiar with them. What I'm interested in is this process with the Witt. Even when we had draftspeople producing these drawings, they would go through a series of sketches, they'd confer with Witt, and then they would actually then produce the work. So there's this interpretation of the text to different kinds of sketches to a final decision. And for me, what's really fascinating about Witt is we have this short piece of text, maybe 5 sentences or so, then that gets translated into a week of work for a team of people doing backbreaking work on a wall. And this gap between the idea and the execution, for me, is really fascinating. If I were going to talk longer about this topic, I'd talk about Manfred Mohr, I'd talk about Vera Molnar, and I'd talk about Harold Cohen, but I'm going to push on for now. All right, next topic is coded form. I'm going to do something dangerous. I'm going to do live programming. All right, so about 10 years ago, Ben Fry and I developed this programming environment called processing. And we did it because we wanted a better way to do our own work and also a better way to teach students. I've been teaching now for around a decade. And when we draw a line in processing, we draw a line like this. We say line, and then we're back to our coordinate system. And then we hit run. Then that line is then rendered within the window or the frame that we just built. So if we want to extend it into areas which I think are more interesting in software, dynamic systems or interaction, we add a little bit more structure. So we say void setup. We give it a size which is a little bit larger than 100 pixels. That's really constrained. We say void draw. And the code inside draw runs continuously until the program's stopped. I'm going to give it a relative coordinate. So I'm going to say width divided by 2 and height divided by 2 for the start of the line. And then mouse X for the ending point and mouse Y for the ending point of the Y coordinate. And then I'm going to run the program. Then you'll see now we have a system, really simple system for drawing. And it just draws a line to wherever I choose to position the line with the cursor. And sort of that's how I draw. I draw in this way by sort of encoding my visual ideas into this form of a computer language, in this case built on Java. This is a different technique for programming education, design education, in a few ways. One, because it's indirect. You're not actually putting the line with your hand or on screen. You're defining it through a notation. And it's a radically different way of pursuing sort of computer programming education because it's visual. Designers and artists can, within a few hours, start to make drawings that they find exciting rather than spending months doing text-based and mathematical-based assignments. So when computers first started to be used for drawing in the mid-1960s, accuracy, precision, these are things that, of course, come to the front. My own personal interest in using the computer to draw is drawing systems that allow for the phenomenon of emergence. So this is a piece by Jared Tarbell called Substrate. I'm just going to run this. Whoops. So the process that it's following can be really simply explained. Basically, draw a line and keep drawing that straight line until you hit an edge or another line. When you hit an edge, you then spawn two new lines that are perpendicular to yourself on either side. So through this very short instruction, very concise, we see something that is intricate begin to emerge from that. So this is the property of software that I've been exploring and the one that I'm going to now sort of move into discussing. Microimage. This is a series of drawings that I started about 10 years ago. To me, they look primitive now, but I think they're still interesting to show. And they're based on the work of Valentino Breitenberg. Valentino Breitenberg is a neuroanatomist, and in 1984, he wrote this really elegant short book called Vehicles, which takes his sort of lifelong experience with neuroanatomy and condenses it into a series of short hypothetical machines. So you can see here from biology we have a sensor, for example, an eye or something connected to a motor. Here we have a cross connection, and here we have a little bit of both, which is more what happens in nature. What we can see is that if we start adding in relationships, for example, here we have an inverse relationship between the sensor and the actuator, and we have a stimulus in the environment, that this wiring, this mechanism, creates a behavior. Breitenberg called this wiring aggressive and this one curious. This one approaches and then moves away. This one basically attacks. So let's look at some software again. So this is a diagram based on Breitenberg's Vehicles, and it's kind of the simplest first thing to do. And this is the first thing I did a day after reading the book. I was curious to see what would happen if I made a simulation of these different vehicles. And here they're color-coded. The different colors represent different wirings. You can see when I add more into the situation, how over time they start with an even distribution and then they aggregate together. And by changing the parameters of each one, for example, how far the sensors are from each other, or what the relationship between the sensor and sort of the little simulated actuator is, we get many different kinds of behaviors. You can even add a little bit of jitter, which creates a more organic motion. And as I was doing this, what I thought was more interesting than the position of these individual elements, these little machines, was the paths that they took over time. So, for example, now we're looking at lines that are just the history of its positions strung together into a single linear element. So from there, I started doing work that I considered to be more visually interesting. And these were the path prints, which we see here, these tissue prints. And when I was producing these images, they were done in a real-time way. So these machines are moving on screen, and I'm moving around the elements. I'm pushing and pulling them where I want them to be. I'm choreographing them as it's running. And I'm in control at two levels. I'm in control of the individual behaviors of the small machines and also in the environment itself. This is an enlargement. This is another print from the same series. You can see here how they're exhibited. Each row here is one parameter set. And then basically I'm mapping some of the possible space made with each parameter set. Lately, as printing technology has been enhanced, I'm able to start producing these at larger scale. And then at this point, I shifted and moved away from the real time. So I think, as you know, if you're working with software, you're working 30 to 60 frames a second, you're limited in the number of elements you can work with. So in that case, I was drawing 2,000 around with 2,000 machines at a time. Each one had line lengths of up to 200. So I'm drawing many thousands of lines a second. I moved away from real time and moved to rendering. And then now I'm working with 500,000 lines. And you can see that it gives the quality of the image a very distinct feeling. It's less about linearity, more about massing. Here you can see an enlargement there. And again, these colors are color-coded based on the wiring of the vehicles. So red is one wiring, blue is another wiring, etc. Removing color in order to see the core. And then here's a photograph of one of the actual prints, so you can see a little bit of the material of the object rather than the simulation of it. Of course, it's still being simulated. All right, next, process compendium. So in working with emergence, I started developing things in this way, doing these kinds of pieces of software. And from here, I arrived at those forms through doing what I call sketching in code. So let's look at that. The idea of sketching in code is that you work through ideas in a way. You first sketch by hand and then move over into this representation. Because there's things you can do and see in code that you just can't with a pencil sketch or drawing. So here, the basic premise was, let's make two shapes that know about their boundaries and they move away from each other when they overlap. So next was putting more into the environment just to prove that it worked, it scaled up. Next was to give each one of these circles a behavior, that they moved along a straight line, but when they touched another element, they started rotating. And so this diagram, I wasn't able to see that. And so I did a next diagram where I was able to add in visual information so I could see better what was happening inside the machine. So the yellow dot here represents the orientation. You can see when they're overlapping with another element, they begin spinning. And then so from there, I started removing information. In this case, I've removed the circumference of the circle, and I've sort of added something else. I've added a line. When the two circles are touching, you draw a line between their center points. So in my mind, this is a process kind of analogous to doing continuous sketches by hand and refining ideas, but it's done in a different medium. Now I've removed everything but the lines, and they're white or black depending on their length. And then so that led to this experiment, where here I'm positioning them in different orientations. So there I was positioning the circles around the circumference of another circle. Here from a line, and then because they have this property that they move away from the other elements, they push themselves out. So starting with these different initial conditions, I'm able to cause different drawings to grow. So here, again, I'm looking at the orientation of the element rather than the lines between them. And so that's a process that I follow in doing all of this work. So that led to this work, which I call the process compendium. And it's based on a series of geometry and a series of behaviors. So circle is my starting point with geometry. We move it in a straight line. We constrain the surface. We change direction while touching another element. And we move away from the overlapping element. So that's the work before, but now described more clearly and plainly. Here we have element 1, which is an aggregate of form 1 plus behaviors 1 through 4. And then here we have the diagram we were looking at before, but it's a little more clear. We can see the orientation. We can see the rotation as they touch another element. We can see moving away from the other elements. But then, of course, now that this is encoded as text, simple English instructions that everybody can read and understand, we can interpret it in different ways. We can start with different parameters and see how the system unfolds according to the new parameter set. Again, these are diagrams. All right, so we have element 1, and then we have element 5. Element 5 uses a line as its core geometry and has two new behaviors. Orient toward the direction of the element that it's touching and deviate from the current direction. So over time, they begin to aggregate together as they assume or average their orientations. This is the full library that I have at this point. It's very minimal, very constrained, but I'm capable of doing a lot with it. It's kind of the property of this process. So then I define it as another piece of English text, which defines how it's imaged. Draw a line from the center of elements that are touching, set the value of the shortest possible line to black and the longest to white, with varying grays representing values in between. So this is the software that is process 4. I'm going to let this run for a few seconds. So it begins at maximum entropy. Everything is randomly distributed. And over time, order begins to emerge as the behaviors are followed. So this is process 18. It's based on element 5, which were the lines we were looking at a moment ago. It says draw a quadrilateral connecting the endpoints of each pair of elements that are touching. and increase the opacity of the quadrilateral while the elements are touching, and decreasing while they're not. So again, starting in entropy, and then order begins to emerge. But when I exhibit this work to the public, I show them side by side. I show the element, and then the process, and then the instructions on the left and right. So for me, it's really about the process. It's about the diagram and what the diagram produces. And here you can see a version of process 18 that's presented in that way, where both sides are the same thing. One is an instantaneous view. The other is the aggregate view over time of drawing these quadrilaterals on top of one another. All right, so from that, I then produce a group of additional work sort of on top of that, if I think of that as my core basic research. So this is an enlargement of a print from process 4. This is a print from process 4 that shows different ways that it grows over time. So given initial starting configuration, it grows into each one of these different forms. Here's a 2 projection of process 4. And this is a performance which is literally drawing. So I'm on stage with the largest Wacom that I can find, and I'm drawing as the music is performed. This is Steve Reich's Music for 18 Musicians, highly percussive, phasing, rhythmic piece. And essentially, I broke the piece down into a different series of graphic language, and then I'm writing these marks onto the screen, sort of in time with the music and following the conductor. But then once these individual elements are on screen, they follow their behaviors autonomously. So it's more of my marks, the way I draw, with the machines following their behavior. This is an installation, again, based on process 4. Each one of these disks is an autonomous software process in constant motion. And these are prints based on process 18. So when things move from software, from real-time into print, they change greatly because I have more resolution. I have more resolution in space and more resolution in time. These are some simple mills using the exact same data. And these are some diptychs also based on process 18. And for me, this is the most interesting image because it shows the material of the drawing itself. All right, lastly, we have Chronograph. So this is the project of mine that has the most to do with architecture and the least to do with drawing. But it has a lot to do with collage. And so I think of collage the same way I think of drawing. It's a way of quickly iterating ideas. It's a way of thinking in a way of putting things into physical space so they can be discussed with colleagues. So this project's a collaboration with Tal Rosner. And this was a commission for the New World Center, which was designed by Gehry Partners. It opened about 1 year ago in Miami, Florida. There you can see a little bit more of the context. And there you can read that one clearly. And so to produce this project, we took photographs of the building over the 2.5 years that it was being built. And we produced thousands of collages. And from those thousands of collages, which you see here, some of them, we made 365 different compositions. And the point of this project was to have a marriage between architecture and music. So bringing rhythm and flow and pattern in time, using architecture as the core base visual element. And so of the 365 compositions, each one is displayed on the wall for 1 hour. And then at the end of the hour, there's a transition where it iterates through a series of splices of other compositions and then lands on the composition that will be live for the next hour. And in doing so, we are basically excavating forms that were captured while the building was being constructed and then representing back onto the surface. For me, it was a pleasure being in this building on and off while it was being built and finding these forms and being able to present them back, because I think in many cases they're fascinating forms that are entirely disguised as the final layer or surface gets put onto it. And so this is one of the compositions. This is the individual element that makes up that composition. And there's a lot of software and logic behind that. And again, we went through a sketching process of writing software, simply iterating, improving. And then we ended up with this, a really simple data format where we parameterized everything. And basically, we sat out on the lawn in front of the building for a few nights, tweaking these values by 1/100ths in order to make it work, to tune it within the context of this 4-story projection within this public park. So, am I over on time? All right, I'll just show this. I'll show the software quickly. So this is a representation of the software, and you can see the quality of the motion. It's meant to be an ambient display. Of course, when it's 4 stories high, it attracts more attention than now. And also, it's really suited for that space. The forms echo forms of the building itself, and the Art Deco neighborhood around. And so in a way, it echoes that. I'm going to iterate through some of the different compositions. And it's not meant to be cinematic. It's not meant to hold your attention, but to become a part of that space, to activate it at night. And so it's also meant to be a clock as well. So a little bit of energy is put into it every second, and that energy dissipates over the course of the second. Actions happen on the minute, and then the largest action happens on the hour, which you can see here, basically marking the time by the number of transitions that it goes through. So that's the end of the presentation. I don't have a grand conclusion, but I look forward to hashing things out in the panel. All right, thank you very much.
All right. I'm Michael Young. I'd like to thank our 5 speakers. These were some incredibly insightful, provocative, and entertaining presentations we had this morning. And thank you very much. Let's see what we can do for discussion now. We have to end by 1, so I'm going to be very brief, and then we're going to open it up to the audience. I'm sure there's many questions that I would like to ask. The one thing, though, that I would like to maybe offer for starting some discussion amongst the panelists are, I think if we take face value, this is drawing dead question, literally, it's almost rhetorical. Drawing's not going to die. It's been with us always. We've always made marks of some sort. But, and whether or not those marks are done with graphite and paper or the illumination of pixels and then associating them in a collinear relationship, there's still lines. There's still marks that we're going to be able to use to describe architectural elements, calculations, or visualizations. The question I think that comes up from several of our panelists here, one that I think we do need to think about and is a very interesting arena for thought, is maybe it's not dying, maybe drawing is being moved from a more central condition within the architectural practice, within the architectural discourse, and if that is so, then what is replacing it? And I think we'd have to say that maybe that is the digital model. In many ways, the digital model is becoming the core concern of the majority of practices, the majority of architectural studios. So then we need to ask ourselves, in terms of the difference between the digital model and a drawing, are these differences minor, trivial? Are these differences radical and game-changing? And how we come to terms with that really is my hope for a conference like this. My hope for what we can understand in the changing nature of our mediations, how we can push things forward, how we can experiment with the issues at hand. What does it mean to work through computation? And we have somebody like Casey Reas who's showing us computational work who, I mean, I have to engage it on an aesthetic level. It's proposing absolutely traditional, beautiful, but incredibly new ways of engaging things like the loss of edge or intensity and density and the visualization of depth. And this Marvin Chun's explanations of how we see depth funnels right into that too. And with Andrew Witt's presentation about the history of the mechanization of drawing, we see that this goes back much further than just the 90s. This has been happening for decades, if not centuries. And so it's wonderful to see, wonderful to give us that contextualization of that history. And I think that Mr. Schumacher would probably say that the digital model has made a fundamental change. And the question then is, then what can we do with that? How do we talk about that? How do we begin to argue with it and argue for it? And I have a little bit more questions for you, but maybe later. And
maybe now.
Well, I mean, it's you know, you try to be moderate as a moderator, but eventually immoderation is going to come. So all right, we'll just jump into it because we might as well light the fire early and then we'll see how it burns out. It might burn out really fast, it might continue a little longer. I think we need to have a conversation about parametrics as architects. I think it's fundamental. We're all parametric architects at a certain level, and NURBS curve is a parametric entity. This is fundamental to what we do. It changes the way we think about things and how we interact with the environments, the digital environments that we design in. Now, in that, the problem that I see, and I guess I'm moving right into the question for you. Why do you have to present the way that you're presenting? It's You seem very intelligent and very sensible, and in some way I'm asking myself, why can't I stitch this together? I mean, I know maybe it's my fault, but why can't I stitch together the argument? Why are you presenting what is actually the kind of opposite condition of how Zaha Hadid initially got brought to us, which was she was able to convince everybody through her mediations. She was able to gather allies around her, if we want to talk about some of the other connotations to social networking and actor theory and everything else you're bringing up. And then people maybe got critical about whether there was a theoretical conceptual discourse to kind of follow that up. You're almost doing the opposite thing. You're almost trying to give us the discourse without the images. And the problem is you have the images. You do. I mean, you have, with Zaha, you have more images than we could possibly ever muster for the strengthening of this argument. And why this is a specific concern for me is because I think we do need to talk about the parametric, and whenever I bring it up, two things happen instantaneously. Oh, are you talking about BIM, or are you talking about Patrik Schumacher? It's almost like the conversation gets shut down right at that moment. And I mean, thinking about just some of the presentations we have today about parametrics, there's a whole wild and wonderful world that we should be engaging. And I can't change you in the way you want to present your discourse, but there must be something, there must be some other way to begin to drive this conversation in architecture in order to not shut it down, right? But engage more and more people, engage more and more disciplines. So I know that second part's more of a comment and not a question, but how you could understand it now is specifically, if you could formulate, for me at least, how you understand the major differences with the digital model from the drawing medium as it existed before, and how that then begins to provide new opportunities for us as architects to think, represent, mediate, convince the world that our ideas are valid. Well,
first of all, I mean, it's true that I feel that my presentation failed on a number of levels this morning, but then I think Casey stepped in and made some great demonstrations where you can see the just the enhancement of the capacity to build up what I would call rich, complex environments, and that's, I think, what we need. We need to increase the complexity of the built environment because our society is more diverse, more differentiated, more complex, richer, and to build up these environments with more variables, with more concerns, with more constraints and demands, we need these new tools. And I think we can no longer rely on a handful of Platonic geometric shapes which we compose, we can track on a piece of paper and build up as a handful of figures kind of collected and called it composition. We need to have more aspects constraining the build-up, but we also need to proliferate the ontology and repertoire of primitives and aspects. So we're talking about gradients, we're talking about much more layered and dense environments, and we're talking about drawing more affiliations and connections, letting elements resonate with each other, represent each other, affiliate with each other, and for that we developed a tool. Of course, there's a congeniality between what we start to desire and what we can do. I mean, we always finding the tools gives us clues about what we yet want to achieve. So there's a dialectic, and you look back at it after kind of 20 years of cumulative engagement with these new potential, new tools. The space pervaded and the difference of results is, I find, quite striking. But ultimately, I find it liberating and fascinating to work with nearly become self-organizing systems that you sketch with scripts through series and reseries, and I think processing is a great tool which we're exploring, in particular in the academic environment. And not only the kind of endless buildup of element upon element, but the kind of interactive and interconnected, self-organizing formal systems, multi-layered and multi-ontology systems even, I find that's where I find the key striking difference, and that, of course, that this also connects with the parallel buildup of production capacities and the translation capacity of these explorative side of things is also extremely important. So there's, on the one hand, we have the kind of explorative digital sketching, which replaces to a certain extent the hand sketching, and the hand sketching still interacts with that. And then on the other hand, we have the world of making this precise, making the technological feasible, making that into a really sophisticated product. On these two planes, I think we've gone quite far, and simply the superiority of the total media panoply for me is striking, and that's why I say what is left behind is perhaps older versions of trying to do that, and these older versions simply can no longer compete.
Are all the mics on?
Yeah.
All the mics
Okay.
should be on, yes.
I think for me, one of the things that Patrik is getting at, and I think might come to the question about the relationship between model and drawing, is really, in a particular sense, the question of the question of combinatorial generation specifically. And I think that's one thing that's been with this sort of parametric approach and some of the historical examples, really almost from the beginning. There's this aspiration that through the combinatorial approach and through the editing of that sort of combinatorial generation of possibilities, that there's one possibility or a few possibilities that will perfectly suit the design problem, which I think is a totally distinct project from where the drawing comes from historically, with a great deal of intentionality, a great deal of, as we've learned, a sense of decision. Right? And I think there's some fundamental tension there and a fundamental question about whether this sort of parametric approach in and of itself requires or prescribes that sort of combinatorial interest. I'm actually myself a bit skeptical of it, because the process of genetic innovation in that sort of code seems so ill-suited to the intentionality of a specific mode of experience, right? That I don't know if it's possible. I mean, I think the aesthetic results are phenomenal, right? But are those architectural results? I don't know.
Julie Dorsey, you should step in. You're nodding your head, and I think one of the things you're trying to get after is bringing that intentionality all the way into a further state of digital model.
Yeah, and I would agree with Andrew that it's kind of bizarre to think that genetic algorithms could be used to generate architectural form. And it's funny when you look at various modeling systems that generate form, and you see someone sort of pick a form, and if you know something about where that technology came from, it just seems very bizarre. But I think what could be interesting is if one starts to generate a form with sketching, sort of traditional sketching, that then one could perhaps look to a body of techniques that might try to fit a range of shapes to that sketch, but not in a rigid way, in a way that would kind of establish a dialogue. I think that could be pretty interesting.
I think there's some aspect of combinatorial inflection once the decision is made and the trajectory is taken that maybe is a way to inform that, to fold that logic back in.
Okay.
I think we should open it to some audience questions. Do we have some? We have one right here.
Is this on? This is on. Very good. I have a question, I guess, first for Patrik, and maybe you can bring Marvin in. Patrik, you used a simile of comparing architecture to the economy and currency to drawing and form. With the into the economy, the function of currency is based on its the known value of it and its finite amount. with the explosion of drawings and form, at what point do we reach Weimar Germany in 1932?
I think that's a very interesting, you put your finger on an interesting aspect of this analogy, which is the danger of inflation with these specialized success media. So you have the danger of inflation, of course, in the money medium, when price and value diverge and you lose trust, and in a sense communication breaks down. And then we have to kind of regress into kind of more primitive forms of communication. And the same thing, I would say, is a permanent danger with respect to the medium of the drawing, which we initially need to project forward and convince and bring people on board and have the audacity to communicate radical innovations and make them compelling and draw investors behind it. But there is, of course, also the danger of overstretch as these media proliferate and are used and abused to create visions and ideas and prospects, which are perhaps largely illusory and maybe not so easily distinguished at first glance by the audience who need to cajole and bring on board. Then you have also the inflationary tendency and the kind of loss of trust and disintegration potentially of that authority of the design and architects. And you found those. I'm looking at Peter Cook. You found kind of in the exuberance of a kind of explorative drawing in the late 60s and early 70s into these kind of ideas of modular mega cities and walking cities and mega structures. There was a kind of sense, it was so easy in terms of the technique of drawing. If you had a mode of translation to sketch out a diagram and proliferate that diagram and project linear cities, there was even a linear city spanning the whole equator. Of course, there is this moment of the potential of overstretch and inflation, and the same dangers, of course, exist today when we have on the one hand a wonderful proliferation of an exploratory domain, at the same time the potential of an inflationary collapse of the currency of contemporary digital drawing.
So that inflationary collapse is catalyzed by the homogeneity of the product. Is that
it's also the lack of meaningful, feasible, rational underpinning of these. And I mean,
just a brief follow-up. The reason I mentioned Marvin is, do we have perceptually a limited number of things that we can perceive coherently?
Absolutely. I was about to add in that the analogy works extremely well for understanding information processing in the brain. One of the most basic principles of brain operation is that it's limited in capacity. Our heads are not going to get bigger, and neurons fire at a certain speed. At any given time, people are only able to track up to 3 or 4 objects. And that's why I was able to make you all blind to the gorilla, because once you get over 4 objects, people's ability to track more just drops. And more people you can try to chunk more information into that 4, but the number is 4. And any number beyond 1 is actually a decrement. So I think you always have to keep that in mind. And inflation, the need for economy is a very good principle.
But people can also read fields too, like not tracking individual objects, and you can see differences in fields and pattern matching in an extraordinary
That's right.
way.
Textures, fields, those can be treated by the visual system as one object, or at least it counts as one unit of information. And so you can extract more information from the statistics or the summary statistics of a broader image. But still, there are limitations in the detail there as well.
Feel big into the
My question is for Julie Dorsey. I'm Doug Cooper from Carnegie Mellon. I'm so impressed by the way you're able to take freehand drawing and set it into a 3-dimensional framework so that we can move through it. What I'm curious about is, have you looked at the possibility of not treating these sketches in strictly a 2-dimensional way? There's a very interesting drawing teacher named Kimon Nicolaides from many, many years ago, who handles drawing in a way that's very sculptural. It's almost non-visual. Have you tried using things that involve pressure on the surface of the two-dimensional planes that you use?
Not yet, but that's something that we've talked about and I think are starting to implement. So your question brings to mind two things. So right now, the canvases are thin. We can use sort of the pressure of a tablet to change the stroke and so on. But one would, I think, like to have a thick canvas where you could, sort of have a planar element that has many levels within it in terms of depth, simulating different kinds of papers and opacities and whatnot. But I think what you really make me think about is a kind of representation that might include strokes and then something. Normally people in computer vision, which is the kind of inverse of computer graphics, they want to recognize things. When they see something in a picture, they want to make complete structure. But I think there's actually an interesting place between graphics and vision, which is that there's something in between, maybe a 2.5D representation or the addition of shadow that could give you an enhanced perception of something. Again, being able to see more possibilities. That's a great observation.
Okay, we have time for one more question. Cam.
I guess this is probably directed a little bit towards everyone. One of the things that was very striking in hearing the presentations today was about constraints and the absence of constraints. So it seems to me that we're in a fairly unusual historical moment in the lifting of constraints in terms of how we draw and what we can build. And the practices of Gehry and Hadid are very emblematic of this. And I guess what interests me is the question of, okay, so now we can do all of these things, but is it interesting to actually think about introducing constraints? Because if you look at practically any architectural situation in history, you see that it's the play against those resistant forces that actually leads to invention and real kind of moments of breakthrough. So what's the pushback now? And if we don't have pushback, do we put it in? And I think in this regard, I think actually Casey's talk was very interesting because you are introducing constraints in this very kind of simple way. There's a very limited number of operations that you're allowing the computer to do, and I think the results were really very intriguing because you were showing the myriad possibilities within those restricted, controlled parameters. But I think thinking about Gehry and Hadid's practices, I don't know what those constraints are. And anyway, that's just...
Coming from outside the field, I'm excited about more ambitious and fantastic architecture. I think the constraint of the body is the constraint that we should think about and work with rather than other kinds of constraints.
And I think many of the fundamental constraints around architecture, like the body, like site, like economics, like material, those are things that are fundamentally unchanged. We just have much richer ways of engaging them, right? So we can deal with those things much more in terms of process and a sort of holistic understanding of where they begin and where they end than we ever could before. And so it allows us to be more versatile with the sort of permutation of those constraints. But a lot of the fundamental things around design are totally unchanged. In fact, they may be amplified with the removal of other constraints.
I mean, I want to come in and set the scene. I mean, we all talk, what we're trying to reach out for is this kind of complex, variegated order. And I think where we want to create environments where many different audiences and forms of communication and events, scenarios are kind of coming into close proximity and are offered up as choices for urban dwellers to kind of participate simultaneously in many and fast sequences. That's what I call kind of the condition of post-Fordist network society, where each of us needs to remain in touch with what everybody else is doing, what else is going on. We can't afford to kind of disappear into isolated, separated corridors, cells, and be away for ourselves. So that means everything comes close to each other. And then the kind of tools we're developing, this kind of pliable, malleable primitives which resonate with each other, where deformation means information, where waves and ripples and affiliations radiate through the texture of space. This is a kind of setting the scene, and those are the constraints, the complexity of sites, the elements we need to affiliate to with our buildings, all the internal program differentiations and complexities and how they recognize each other and communicate with each other. Under the headline, everything communicates with everything else. And I think that for me it's very important also to see the kind of reflection on the perceptual tractability and comprehensibility and legibility of dense, complex scenes and urban environments. And I'm thinking a lot, and my presentation and most of my presentation are reflecting on Gestalt psychological laws of decomposing complex scenes into units and units of interaction. What are the multiple readings which I can embed in complex environments, so that different audience at different events filter out and analyze and decompose and compose the scene with respect to at this moment relevant units of interaction. That's to me the key problem, and that's I think what also is the advantage of that new style where we work with curvature, with continuously changing curvature and gradients, where you can keep more elements in tension and remain legible, a more complex and information-rich environment, whereas with the older modes of composing kind of stiff elements and agglomerating them as disjointed figures, you ultimately, if you build up complexity, you end up with this kind of garbage spill or visually impenetrable white noise of fragments. Mm-hmm. So for me, that's the key problem is, and task of architectural articulation is to build up this complexity, to make it objectively present, but make it legible, perceptually palpable, and navigable. And that's why I'm very happy with to have this kind of this discourse, and we do that intuitively. We're continuously visualizing and re-visualizing the compositions and testing out whether we kind of find ourselves, whether we can isolate and identify moments at it, and even though these become ever more rich and difficult to perceive environments. But I also believe one thing, that we as urban dwellers also have a learning capacity. That's why I'm curious that you're saying you can never perceive more than 3-4 elements. If I think of how we're able to channel hop and see rapidly cut television ads, I think there is also on the subjective level capacity to grow with these complex urban environments. And that's why I'm a little bit skeptical with this kind of sense that we need to kind of be given kind of trees and water bodies to kind of calm down. I think we need to bear and have the lust for inhabiting that new complexity, which makes us productive.
Okay.